Hello everyone, welcome to Acropolis Institute of Technology and Research. I am Deepak Singh Chauhan working here as an assistant professor in Information Technology department. In this video, we will discuss about polymorphism in Java. So let's continue. This is the table of contents that we will discuss in this video. That is, first we will discuss about polymorphism and different types of polymorphism, compile time polymorphism, an example of method overloading, method overriding, example of method overriding, and the runtime polymorphism and its example. Okay, so we will discuss everything about polymorphism in Java, how it can be implemented in Java, what are the different aspects of polymorphism in Java. Okay, so let's continue with the polymorphism. What is polymorphism? Polymorphism is a combination of two words that is called poly and morphism. Poly means having more than one, and morphism means form. So whenever something has more than one form, then it is called polymorphism. Okay, or we can define polymorphism as an ability of an object, variable, and a function to take more than one form or multiple forms. So whenever something has more than one forms, or it can behave differently with different types of inputs, so we can call it polymorphism. Okay, so this is the definition of polymorphism. Let's discuss about the different types of polymorphism. So there are two different types of polymorphism, or we can say that Java support two different types of polymorphism. Compile time polymorphism, or we can also call it static polymorphism or static binding. Static binding means what, or compile time polymorphism means what? Whenever the call of a method will bind at the with its definition at the time of compilation of the program, then it is called compile time polymorphism. Okay, and this compile time polymorphism can be implemented with the help of more method overloading in Java. The second type of polymorphism is runtime polymorphism. So as the compile time polymorphism, when the call to a function or a method is resolved at the time of run of a program, then it is called runtime polymorphism. And method overriding is a mechanism by which we can implement the runtime polymorphism. Runtime polymorphism is also called dynamic polymorphism because it can change at the run of the program or runtime of the program. Okay, and static polymorphism cannot be changed at the runtimes. Once it is fixed, it cannot be changed. Okay, so these are the two different types of polymorphism that Java supports. Now, compile time polymorphism or method overloading. It is also called static polymorphism, as we have already seen. So it is achieved by creating multiple methods with the same name, but with uh, but with each one having different number of parameters or parameters of different types. Okay, so whenever we have a method with the same name with different number of parameters or different types of parameters with same numbers, then it is called method overloading. Okay, so method overloading is a way by which we can implement compile time polymorphism. Okay. So this is an example of method overloading. Here we have a class called multiplier. In this multiplier class, we have different versions of multiply method. Okay, so as we can see in this example, one uh, one method multiply is taking two arguments and multiplying the two arguments of integer type. The second method or second version of multiply method is taking two arguments of double type. Okay, here the type number of argument is same, but their type is different. Okay, so this is also an example of method overriding. Sorry, overloading. Then the third version of this multiply method is taking three different argument of double type. Okay, and multiplying the three different variables. Okay, so this is the example of method overloading in Java. Okay, we have three different versions of multiply method. Multiply method means what? Their name is same. Okay, so let's move on. Okay, so here we have going to test this method. So this multiply method, the name of the method is same. Okay, as we have created a static method, so we can call it with the help of the class name itself. Okay, so we are calling multiply method for two parameters for the first version, then the two parameters of double type for the second version, and the three parameters of double type with the for the third version. Okay, so it will respond accordingly. Okay, because we have overloaded this method, so we have the freedom to call this method with different types of arguments. Okay, then there is a concept called method overriding. Okay, so as in method overloading, we have seen that the name of the method is same, but their parameters are different. But overriding is a feature that allow a subclass. Okay, it is generally used in the inheritance hierarchy. Okay, so it is a feature that allows a subclass or a child class to provide a specific implementation of a method that is already provided by one of its superclass or parent class. Okay, so whenever we have defined a method in parent class or superclass, and again we are defining the same method in its subclass, then it is called method overriding with the same name, same parameters, and same return type. Here name of the method, parameter of the method, and return type of the method will be same, but their implementation will be different. Okay, so when a method in a subclass has the same name, same parameter or signature, and same return type as a method in its superclass, then the method in the subclass is said to override the method in the superclass. Okay, so let's see an example of this. Okay, so this is an example of this. We have a class called vehicle. Okay, in this vehicle class we have a run method. Okay, and it has its own implementation. Now this vehicle class is extended in the bike class. Okay, now in this bike class we have again defining the run method. As we have extended this vehicle class in the bike class, so this run method is implicitly available in this class. Okay, this bike class. Okay, so again we are redefining the run method. Okay, and this run method has its own implementation. Okay, so as we can see that the run method has the same name in both the parent class and the child class, and same number of parameters, as it is not going to take any parameters and the return type. So this is an example of method overriding. Okay, so this method overriding, what is the use of this method overriding? This method overriding is used to implement the concept of dynamic method dispatch or runtime polymorphism. Runtime polymorphism is what? Or dynamic method dispatch is what? It is a mechanism by which a call to an overridden method is resolved at runtime. And this is how Java implements runtime polymorphism. When an overridden method is called by a reference, okay, Java determines which version of method to execute based on the type of object it referred to. Okay, we will see an example of this. In this simple words, a type of object with which it refers determines which version of overridden method will be called. Okay, so here in example we can see that there is a parent-child hierarchy. Okay, so parent class object can refer to the child class object. Here we can see that we have created a parent class object, then child class object, and again we are creating the parent class object with the child class object. Okay, this is called upcasting. Okay, so this upcasting feature will be utilized in uh, dynamic method dispatch. Okay, so this is an example of dynamic method dispatch. Here we have a class called A, and two classes B and C are extended from this class A, and all these methods have their own version of this call me method. Okay, this call me method is overridden in all these classes. Okay, it is defined in class A and overridden in class B and class C. Okay, now in test class we have created the objects of all these classes A, B, and C, and a reference of parent class called R. Okay, now in with the help of this reference we are calling the different versions of this call me method. First, once we have assigning the object of class A, then calling the class A. So it will call the class A's version of call me. Then we are assigning the object of class B. Then it will call the class B of class B's call me. And again, in third time, we are assigning the reference of class C or object of class C to reference R. Then it will call the class C's call me method. Okay, so this is an example of dynamic method dispatch, with the help of which we can implement the runtime polymorphism. Okay, so in this video we have discussed about all about the polymorphism. Thank you so much.